selective breeding takes place at the queen level. You don't have to punish the workers for that. You just don't only breed from the daughters of the most resistant queens, the most resistant colonies, and we requeen our entire operation. Okay. All right. Okay. So we all know about varroa. And here's the deal in the integrated pest management for varroa specifically. They have integrated pest management pyramids for any kind of plant or animal pest. Generally, you start with resistant stock. Okay. Like with me, I have a large orchard and vineyard, and the grapevines and fruit trees that get a lot of diseases every year, especially a fungus, I just get rid of them and use stock that is resistant. And that would be what we'd ideally do with varroa. Let me hide some. There we go. And we've had varroa for over 30 years here in the United States. Yet most all beekeepers are still keeping stock that has little or no resistance to the mite. And come on, there we go. So what the question is, what's the problem? And there's no lack of queen breeders. There's queen breeders all over the place. And many of them have tried resistant stocks. It's not hard to produce queens, but selective breeding of honeybees is really, really a challenge. And the reason is that every aspect of honeybee reproductive biology focuses on maintaining as much genetic diversity as possible and constant recombination of alleles. The queens mate with multiple drones. The genetic recombination, that means when you're making a sperm or an egg cell, they take some of the alleles from the chromosome of the father and some from the mother, and they switch them back and forth. They do this at the highest rate of any animal known, which means it's very difficult to maintain straight lines. Then you have sex alleles, which prevent you from doing inbreeding. So most other livestock, you can mate father to daughter or sister to brother or cousin to cousin. You cannot do that with honeybees. If you inbreed too much, you have this loss of sex alleles and get diploid drones. So those are all contrary to selective breeding. So it's very difficult to selectively breed honeybees. Now, I'm not saying it's not possible. So one of the ways to do it is, as Declan mentioned, is just the bond method, live and let die. And this is what nature does right now. And Ron in England, with his few colonies there, he was certainly propagating stock, but he likely was not doing much breeding. It was nature doing the breeding of all the feral stock around him that was suffering from the bond method, live and let die. And those that were susceptible to varroa, they just died. And those that were resistant, they survived. And he had the benefits of getting the matings from all that's around. And this has happened also in other countries, in Cuba, South Africa, where they did not treat for varroa. In a few years, South Africa, about 6 years, all the stock of bees that survived was resistant to varroa. So most of us, though, don't want to lose all our colonies. So there are breeding programs going on. Many of them are very, very tedious, involving brood dissection, much record keeping. And the question is, are they really necessary? And I see pictures of these teams of people just dissecting brood. This is me doing it myself to look for resistance traits in them. Then Dr. Marta Spivak started with the freeze-killed brood test years ago. Very, very good for finding bees that are resistant to American foul brood and European foul brood, possibly chalk brood, but dead brood diseases. Does not correlate very well for varroa resistance. Kara Wagner has a new unhealthy brood pheromone out that looks like that may be much, much more useful, and I'm looking forward to being able to try that. Also, instrumental insemination. Well, that's really handy for single drone inseminations and inbreeding, but I don't know if it's necessary for breeding. by tradition, beekeepers simply, and all, you got to realize that most all plant and animal cultivars that we use were selectively bred before anybody ever heard the word genetics. Okay, they just did it by observation. So all these breeds of sheep, all the breeds of vegetables, they were bred before anybody knew about genetics at all. Again, they just observed what they had. And it's not magic. It's a simple process of selection at each generation and just having the patience to do this. Now, there's two kinds of selection. And Jeff, can you tell me if you can hear me? I can't see anybody in the audience, so I have no idea if anybody even hears me.
Yeah, we can hear you loud and clear.
Why don't you leave your picture on? Then I know that I'm not just talking to a blank wall.
Okay, you got it.
All right. So there's two selections. That's negative selection and positive selection. Okay, so negative selection. You don't breed from the undesirables. So you don't breed for bees that are super defensive. You don't breed for bees that die from shockroot or other diseases. And now you would not breed from bees that are very susceptible to varroa. On the other hand, there's positive selection. That means you breed from those that exhibit desirable traits. So from the wild cabbage, all these different plants from the Brassica oleracea complex have been bred by simply breeding for larger flower size. These two, both flower sizes, more buds on the stems, very big leaf balls. These all are just in mustards that have been bred from the same original plant for these positive traits. The other thing is, you're not, if you're doing selective breeding for varroa resistance, you're not creating any new alleles, any new genetics necessarily. It's really rare to come up with new actual genetics unless you're doing mutagenesis, gamma radiation or electron beam radiation to cause mutations. Mutations are relatively rare. What you can create new combinations of existing alleles that's already in your breeding population. So pre-existing alleles. So new either coding combinations, so for proteins, or mainly the regulatory genes, putting together new combinations of the regulatory genes to use the existing tools that the bees have. But every population of honeybees, as far as I know, already has all the alleles necessary for mite resistance. You just have to breed for those that put them together in the right package. So if you are going to do selective breeding, start, I suggest, with stock that is adapted for your eco region. So bees adapted to Southern California would not be necessarily well adapted for bees up in Minnesota. You have a much different winter. Then prioritize your selection goals. Now, the word fitness has nothing to do with strength. Fitness means how many grandkids you have, not just children, but children that survive to have children again. That's your fitness value. So when biologists talk about fitness, they're talking about reproductive capacity to go on to future generations. As far as that, you're never going to improve upon wild type. Wild type is always the most fit because that in that environment, because nature selects for it ruthlessly every single generation. So you're not going to improve upon wild type. For example, humans have been selectively breeding wolves for about 7,000 years. And the epitome of breeding wolves after 7,000 years is this wolf right here, okay? Would this be the most fit wolf out in the environment, living in the wild and foraging? And would it be able to reproduce as well as these wild type? Unlikely. Wild type is always the most fit, and the same with the honeybees. The other thing, there's some beekeepers that breed for looks. They want the yellow queens or queens with a certain pattern or something like that. That is something that we just absolutely abandon. We like to see a whole rainbow of different colors and patterns in our queens, because that's an eyeball characteristic that suggests that we're maintaining enough genetic diversity in our stock. If they all looked exactly the same, we'd be worrying about too much inbreeding. So the second thing is, when you start breeding for looks, say just the fattest queen or the most yellow queen, you only can breed for a very few traits before you wind up with no breeders left. If you're breeding for the best out of 100, for one trait, say honey production, that means you have to have way over 100 before you can breed for a second trait, which means gentleness. And then if you look for winter survival or varroa resistance, pretty soon you're not going to have any stock left that's going to be in your best of all those traits. So narrow down the number of traits you want to breed for. And there's no such thing as a free lunch. You breed for one thing, you're going to lose something else. Go to my website, you'll see the trade-offs of selective breeding for different traits. If you breed for large colonies, you're breeding against frugality. If you're breeding for early buildup, greater consumption of pollen stores and stuff. Increased egg laying, that'd be reduced queen longevity. So there's trade-offs on every single trait. So understand there's no free lunch in breeding. So the question is, let's just say you decide to breed for a varroa-resistant stock. There's a number of known resistance traits and a whole lot of unknown resistance traits, such as they found in Norway, molecular biology, where the bees naturally bred to regulate the expression of a gene for an ecdysteroid that is necessary for varroa. So that's molecular biology the bees are using against the mite. Who would have ever thought to breed for that trait? That would never happen. So what I've decided to do is not to tell the bees how to do the job. Let the bees figure it out. We don't really know how many genes or alleles or genetic cascades are necessary for resistance, or whether they all have to be the same. Apis cerana is extremely resistant to varroa. It uses entirely different mechanisms than Apis mellifera comes up with when left on its own. So totally very similar bee, but they resist the mite very different ways. We also don't know if a queen mates with 20 drones, it may only take one patriligne, just the workers of one single father in that colony to express enough resistance to keep the entire colony resistant to the mite. We don't know how many, or whether we need two different patrilines, say one to uncap the cells and then one to remove the mite-infested pupae or larvae. Oh, another thing, what Declan said, quoting Steve Martin, is that as far as deformed wings, we used to see deformed wings as a good indicator of high mite levels. And now all we look for is the death of the pupae, the fifth instar larvae and the pupae. That's what we see long before we start seeing deformed wings. So pupal observation is a better trait to look for. So what I decided to do is, because the other queen breeders had given up pretty much, queen producers, on breeding for mite resistance, I tried a keep it simple, stupid model and see if I can just use traditional breeding techniques and breed from my own stock. We already tried what most people do, which is you go out and you buy a quote resistant queen from this stock and one from this stock, and you bring in a Russian, you bring in a Saskatraz, you bring in whatever, you breed them all together, and you think that magic is going to happen in your yard, and you're going to put a bunch of random parts together and come up with this incredible new queen or stock. What you wind up with a bunch of Franken bees, just worthless bees. So just skip that altogether. Start with your own stock. And the model I followed was described in 1999 by John Hargrove and Jeff Harris from USDA. I'm on a Zoom, okay?
Yeah, you got one box of bulk soft on the property. Call me about it.
Oh, thank you. All right, update from my son here. And what they said is that by comparing the growth of mite populations in each colony out of a group of colonies, one can determine which bees are more resistant to mites. I mean, how simple is that? Just compare how fast the mites grow in each colony. So that's the method that I decided to follow up on. The second thing is people mix up the word tolerance and resistance. Tolerance means that the bees can survive despite having a high mite load. That means that they are resistant to viruses. So mite tolerant bees are bees that are resistant to the viruses. What we had to decide was which one to breed for. We had stock, like the Russian stock, is very resistant to viruses and can tolerate a very high mite load. On the other hand, bees that keep the mite load very low, viruses pretty much disappear. So I decided to strictly skip breeding for tolerance and breed for resistance. And as an aside, and Declan would have been interested in this, we have a number of times had samples taken of my mite resistant stock, the colonies that are naturally completely resistant to varroa, compared to colonies sitting right next to them that had very low varroa levels, but got it through treatment. And the virus load differences are night and day between the two. Our naturally resistant stock that keeps mite levels down without any treatments whatsoever have orders of magnitude lower virus infection rates than do the bees sitting right next to them that have low mite levels, but due to using miticides. So you can use my varroa model. If we have time, I'll go back to it. I'll run you a simulation, show you how to use that. But it's a free download on my website. So what we do is just define the job description and fire all of those that don't perform. So our job description for Golden West apiaries here is you got to overwinter in our foothills, then be strong to go to almond pollination, handle being split into nukes for sales, and then go for honey production here in the foothills. That's the job. And our specifications, they got to be gentle. Nobody wants hot bees. And we have a reputation of selling very, very gentle bees. They got to brood up early. Our bees do. So they're strong for almond pollination, remain free of disease, and then produce a honey crop. On top of that, they also have to minimize the rate of varroa buildup to the very, very least. So here's how we do it. Here's the concept. Step one. From your breeding population, identify the very best colonies that have the mite buildup at the very lowest rate. Step two, the next season, requeen every colony or operation with daughters from those colonies that exhibited the strong varroa resistance. And repeat that year after year. Very, very simple. You just breed from the best and you eliminate all the rest of the queens and replace them. So what I use is John Kiefer's modified bond method. John Kiefer was an American researcher, moved to France. Here's a picture where I visited him there, and he used the bond method, live and let die, and he has the Kiefer's varroa challenge. He'll give you a silver French penny for any mite you can find in his colony. It took me a lot of work to earn my penny to find a mite. He lets you go through and dissect all the brood or whatever you want to do. So, but most breeders don't want to lose 95% of their colonies. So there's other ways to do it. And that's the modified bond method, which he recommends. So from your most resistant colonies, produce a whole bunch of queen cells, and then start a whole bunch of splits from your colonies. We split all of our colonies after almond pollination. We then hit them with a shot. We start with a queen cell, and then during the induced brood break, we give them at day 18 a dribble of oxalic acid to kind of equalize their starting mite levels during that brood break. We place them all out in yards. We have 60 different apiaries in our county, and let them start to build up, to grow up into doubles and stronger then. And that's the beginning of the varroa race. And we let the mites then start trying to reproduce in those colonies. And then what we do to select the winners of the race, we use alcohol or detergent washes. That's the only thing we do for monitoring these hives. So in our operation, we start in late March, early April with nukes, typically with a relatively low mite level due to the dribble. And we would expect them, if they were untreated, when we started, you'd easily get by August or early September, a mite wash counts of 50 or so. Okay, sometimes even as early as July, you'll be up to this level. Our resistant colonies, we do a mite wash in sometime in June or July, and look for those that have mite counts of 0 or 1. Those we do not treat. We treat everybody else. And then we follow up on those marked colonies and do a second, a third, a fourth, fifth, and a sixth wash generally on the next spring. And they need to keep their mite count down for the entire course of the year. We will allow them to build up a little bit in November. I was excluding those at first, and I talked to John. He said, no, don't do that. because a lot of them will take it down. We found that, yes. So now we have a cutout of 10 mites in a mite wash in November when they come out of the brood. If they can take it back down on their own to 0 by the time we're rearing queens, then they remain in the program. So we put a stainless steel tag on any that is a breeder and put down the date, and on top of the hive are mite wash counts. And we treat any ones side by side that the mites went up on, and we pull the tag off them, they're out of the potential breeder pool. And no colonies need to die. We don't need to lose any colonies due to varroa in this modified bond method. So the same amount of selective pressure for breeding, but there's no reason to make a colony suffer. The reason is that selective breeding takes place at the queen level. You don't have to punish the workers for that. You just don't only breed from the daughters of the most resistant queens, the most resistant colonies. And we requeen our entire operation every spring only from those daughters. We choose about 30 of our best breeders every year to maintain diversity, and then breed off of those each spring. We queen our operation. And we graft only from colonies that showed very, very good resistance, mostly 0,000 colonies. And then we flood our area with our apiaries and our stock to make sure that we are controlling the drone pool, and we give away free queen cells to any other surrounding beekeepers in here. So it's pretty much our stock alone that they're breeding with. Any feral population would, in order to produce drones, that means they had to survive the winter. So they must be varroa resistant. So that's fine with this interaction with the feral population. So these are our locations around my home, and we just flood this area. Here's my home right here. We repeat that process every spring. So very simple. No, it doesn't cost much, and we get desirable stock. Lots of points of very little record keeping or anything. The problem is the cost of monitoring, the time it takes to do the mite washes. So we focused on getting this down really quick. We do this smoking hot mite washing. Typically with a crew comes out, and with a crew of 4 and somebody watching the agitator, we can go through a yard of 30 hives in about 25 minutes and have a mite wash count on every single hive in that yard. Very, very, very quick. We have this described on my website, the tools we use, colored markers, colored cups, and we sample every hive. We make sure that at first it's gentle and is showing good buildup, clean brood, honey production, or it doesn't even get a chance to be in the breeder pool. So everybody has to be above the yard average. We take a similar frame from each hive. We do not shake bees from a brood frame. That's inconsistent. We shake a frame adjacent to brood, but not containing any brood. That also means that we have much less chance of getting the queen on that frame. So we don't have to look for the queens as carefully. We don't want to lose a breeder queen by pulling a brood frame out and shaking the queen off and possibly injuring her or losing her. These are the markers at the top of the hives, which means that we have the mite wash cup, the red cup being washed, the blue cup being washed, and then we'll have the washer holler back, tell us whether or not to tag this colony. We always frame adjacent to the brood, but not a brood frame. Shake them into a tub. No more bees than this, so we can look for the queen very easily. Let the old bees fly off. Now all you have left in the tub is young bees without a queen. The young bees have a higher mite infestation rate than the bees that fly off. So this gives us a very representative sample of the infestation rate in the colony. Young bees immediately fan out, typically walk in a circle, very easy to spot the queen and figure out if necessary. Then we scoop up a half cup of bees, you level off your finger. I've done this tens of thousands of times. I've never once been stung by doing this. So you want to make all your samples exactly the same number of bees so you can compare them. We dump them into, used to use alcohol, now we use Dawn detergent, works much better. Snap on the lid, mark the cup color on the top of the hive, and the assistant goes out there back to wherever we're doing the agitations, and we go on to the next hive. So it's less than 60 seconds often. Open the hive, taking the frame out, shaking bees off, put them in the cup, close the hive up, bang, you're on to the next hive. Just bam, 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 really, really fast. Back at the stand, the bees are agitated and the mites are counted and then hollowed out. The cups are brought back now, and before she picks up the blue tag right here, if that was a potential breeder, she's got the card in her hand that says what the mite count was and the date, and she'll staple that on top of the hive right there. So there's a hive note right there. And we match the notes to the color. And any ones that are zeros or ones are marked as potential breeders. So total takes about 4 man minutes, counting all the people involved for each mite wash. Okay, very quick. So labor costs maybe $1.50 a hive. That's an important number because that means that's less than the cost of a treatment. We actually save money by mite washing every single hive in our operation in the month of June. One time a year, every single hive in the operation gets mite washed. What we see is we look at the frequency of mite counts. This is back from 2017. You have a few hives that have very, very low mite counts, like 0 mite counts. And then you have outliers out here of high mite hives right here. So we want to negative select these, make sure we replace these queens so we're not selecting for high mite hives. We don't want them, these bombs, we don't want them producing drones in our operation. So positive selection for these, negative selection for the bombs. And the cost of doing this is cheaper than most treatments. If it costs you $6 for Formic Pro treatment, that means we can do 4 mite washes for that price right there. So here's what we're doing in California. I've published how to do this, and I'm doing this not to sell anything. This is a demonstration project for the benefit of queen breeders everywhere. I'm being followed very closely by queen producers throughout the world to see if I fall on my face or whether I have success on this. So just simple breeding, California experiment. So every spring, set up our nuke making tables and we split every single hive after almonds. We make about 3,000 nukes every spring. Put them out in the yard, each with a new queen, start the varroa race. June, July, out hit the field, identify the potential breeders and treat all the rest. Again, using mechanical agitators. And then back here, we use a magnifying mirror underneath to very quickly count the number of mites, record all the data right here. We use these portable agitators. I've gone through a number of generations building these prototypes. I hope to bring one and make it available soon to everybody because these just change the whole game. Having mechanical agitators that allow you to do rapid fire mite washes. You push a button and they do a 60-second agitation. You get 100% recovery of the mice. Just really, really handy. No wearing your wrist out. Then I have a dedicated vehicle, actually. I pull out table right here with a leg on it that we can set them up on and do our mite washes. This is generation 4. I'm up to generation 4C now. So over the years, every year I improve these. I think I finally nailed it down what I like. And I already showed you that one here. And this is the ones that we look for breeding, that they'll have mite counts of 0 time after time for the entire summer and clear to the next spring. Mites cannot reproduce in these colonies simply due to the bees. And they got to be gentle. Here's me in August out on a hot day, I may be shaking 50 to 100 hives, doing mite washes, dressed like this. And so I very well quickly tell you if they're any defensive at all. And they would be out of the program if I get any stinging. Now, here's the interesting thing. Okay, hang on a second. I just talked about progress. Okay, so we looked at in 2017, we started off with about 1,000 hives we tracked. And as we did each subsequent mite wash, the number remaining as potential breeders dropped down. So we had, after the first wash, about 250 or so out of that 1,000 looked good. That dropped the second one down to 10%, 5%, down to 2%. Now we started at the very first year way less than 1%. So things changed over the next years. Now, one thing about breeding bees, and I can see I got some of these slides out of order. I was just I combined two slideshows just before this presentation. Is that the genetics of the drones reflect the genetics of the grandparent generation. Okay, so you always have a 2-year lag in your genetics when you're mating. So that means you can do some pretty strong bottlenecking from time to time. And what saves you from getting too much inbreeding is that lag from the drone pool, which reflects the genetics from 2 years previously. And we count on that in our breeding. We don't want to bottleneck too much. So this is back 2019, looking at our breeder queen counts. So June, August, September, November, March counts. So some of them went up on their own, but they bring it back down to zeros on their own without treatment. That's what we want. Colonies that can bring their mite count down without treatment. And these colonies are very gentle and productive. We do notice they start off as solid brood patterns, but by August, you see where they have removed broods. So they are practicing very strong, not only uncapping behavior, but varroa-sensitive hygiene. And again, read from the zeros. Okay, so I want to go back here. I thought I put another slide in here. Something got screwed up. Okay, we this spring, okay, some people ask me, Randy, so what percentage of your operation are breeders? Well, the problem is I couldn't tell you, are resistant. I couldn't tell you, because when my sons go out and are selecting the first round, and you go to a yard of 40 colonies, and they say, Dad, every damn one is a 0 or a 1. What do? I say, well, why don't you pick the best 10 in that yard and treat the rest, not knowing whether they needed a treatment or not. So we were excluding a lot of colonies from our breeder pool and not tracking them because we just had too many potential ones. This spring, I told my sons, hey, I got a couple of big projects. I need to have about 250 hives that are not mite resistant that I can test for mite treatments on. They said, okay, great. So they put about 400 hives aside from almonds. They split them, but they saved the second-year queens in those nukes and let them build up, hoping that we would have a whole bunch of non-resistant colonies because they came with their mites and they built up. By June, they go, uh-oh, there's way too many hives with counts of 0 and 1. So I said, let's build up to the middle of July. Middle of July, the joke we had was, we need colonies with mites. We don't have enough colonies with mites. So I did histograms here. So this is for our 2 largest yards they put aside. So in July, colonies, all these columns add up to 100%. So this represents all the 93 hives in that yard. These had mite washes of 5 or less, 0 to 5, 6 to 10. And you can see that it's I don't know why I didn't get this in here. You know what? Hang on. I know I saved a new copy of this for Jim here, and I must not hit save yet. I put in the numbers in a graph. A normal distribution, we would expect for this average mite wash to have been low here and peaked here and then gone down. What we're seeing is a distribution skewed strongly to the left, which is indicating that we have a much higher proportion of resistant stock that we were unaware of. We're running probably about 1/3 either fully or strongly resistant stock this last year, which really surprised us just how strong the proportion of resistant stock in our operation is. So this is very, very exciting to us. Since we started, that's over a 300-fold increase in 6 years of selection breeding of the proportion of resistant stock in our operation. So we don't claim mite resistance yet because we're still only at about 35%. So when we get to 95%, we may claim it, but we feel like we're making really good progress on this program. Okay. Let's go through here. So there are a number of ways that they can do it. And there's a bunch of terms that you would I'm not going to go over them all, but there's a lot of things you got to understand about resistance. You don't need for a breeding program. The breeding program, all you're looking at is mite washes. I'm only going to show you the rest of here to help you understand maybe how the bees do it. But if you want to breed for it, you don't have to know any of this stuff. You just do mite washes, and that's all you select for. So mite botting may help to some extent. It does appear to be important, but I doubt it's a major factor in resistance of Apis mellifera. Varroa-sensitive hygiene, where they chew out brood. You can see this brood is white, which means it was healthy when it was chewed out. If it was gray, that means it was dying when it's chewed out. So varroa-sensitive hygiene, we're not sure whether it's due to a signal, a pheromonal signal that the pupa says, hey, sacrifice me, or a signal that the virus puts out, telling the bees to chew it, or what. But this is a very, very important trait. The other one is this uncapping and recapping. And this is what Steve Martin has found to be a universal trait throughout the world in naturally resistant stock. And published this paper recently on this. Anyway, I gotta close something here. Hide so to meet the game. What's interesting is that it's usually clumped where you see recapping. So when the uncapping bee gets the signal from one cell, they tend to uncap other cells around them. And that they often will just recap back over these cells. These resistant colonies, hang on, let me go back here. Okay, so this is interesting. I thought I had another slide in here. I must have lost it, where I'm using wax depilatory pads that women use for, or I shouldn't say women, men or women use for bikini waxing to remove body hair. Well, they work very well for peeling off these cappings, and maybe I'll have the slide show up. You can look underneath it and see where the cell has been recapped. And what I'm finding is this recapping behavior is very common, not only in our resistant colonies now, but even in our non-resistant colonies. So that's a trait all the way across. So it's got to be more than just the recapping. You have to have, or uncapping, it has to be the uncapping coupled with varroa-sensitive hygiene. So what you see here is maybe half of these cells have been recapped, but these actually have had the pupae removed. That's varroa-sensitive hygiene. Dr. Martin's hypothesis is that the uncapping, during which the female mite usually exits and then enters a new cell, that disrupts her reproduction enough to gain mite resistance. And I hope I have more slides of this. The other thing that we see, and I just saw this hours ago, I'm out going through colonies to do a test on a thymol treatment, and I need some relatively high mite colonies to test it. And I had colonies that had mite wash counts on top of the hive taken 2-3 weeks ago, set aside for this test. And I went back today and they had taken their counts down to very low levels on their own at this time of year when we expect mite counts to be going, it's skyrocketing. And I see this again and again in my operation, is that the colonies, let's see, that have not full resistance, don't keep it zeros all the time. So this is from a trial I did on it. I was testing HopGuard, and I couldn't find enough, didn't have enough hives around, and I had a bunch of second-year queens that had failed. So second-year breeders that had passed the first year with very low mite counts, but by the second year, the mite counts were going up to this 10 to 15 mites in a mite wash count. I go, great, I'll use them as for this test. We went ahead and did the mite wash count again and again, and they took their damn mite counts back down. And I see this over and over again. When they start getting up to a infestation rate of around 5%, they go, oh crap, we let the mites get ahead of us, and they kick into gear and they start just chewing those mites up, and they take their mite counts back down on their own without treatment. I see this over and over again. So, and here they are, hitting the brood hard, getting in here, chewing them out when the infestation rate gets up there. very interesting other things. And if you really are interested, definitely read this paper here about the saliva protein and how Apis cerana resists the mite. And then Kira Wagner's paper about this unhealthy brood odor. Here we go. There's the depilatory pad. So if you look here, when you pull off the capping, if it has not been recapped, you see the silk of the cocoon on it, the light color. If it's been chewed out and then replaced, it looks dark. So on these, all these dark ones have been opened up fully and then capped back over. This is a very, very simple test. If you're interested in doing this, to check with your colonies for recapping behavior, I think it's Zeet brand works really well. You can always email me and I'll tell you that what brand depilatory pad works very, very well for doing this. This takes you a minute to do this test.
You said what brand?
I don't have it in front of, oh, maybe I do.
Come on, Randy, we saw you with your shirt off. We know you got some around.
Yeah, right. All right, just move that box. Remind me a question and answer, and I'll tell you the brand. So the whole Achilles heel of varroa is its reproductive success. Just mess with that. You disrupt the reproductive success, the number of mated daughters a foundress gets in a cycle, and that will screw them up entirely. So on my model, you can adjust the amount of reproductive success of a female mite in a colony. On average, most stocks at Apis mellifera have a about 1.4 mated daughters per foundress in a reproductive cycle. That's standard across non-resistant Apis mellifera. So a foundress mite enters a cell, almost 1.5 daughters come out of that cell with her, and the mother may die. And this would be at this rate, this would be your typical mite buildup. If I simply drop that in half to 0.7 instead of 1.4, look what happens to the mite count. The mites barely grow at all over the course of the year. So all you got to do, you don't have to ever kill a single mite to control varroa. All you need to do is just cut their reproductive success in half, and their natural attrition matches their reproduction, and that's zero population growth for the mites. So typically, this is what our first rounds of brood look like in our nukes. Very few holes. And then later on, you see a lot of holes like this. This is where VSH kicks in. Oh, here we go. Okay, so what's happening now is, this is from a few years ago. These are mid-August mite wash counts. These yards, this year, the June counts were all zeros. So we just tried them in July. They're all zeros. No treatment. These are all colonies started in late March. Mid-August, so here are the mite wash counts from 6 different yards right here. Look at all the zero counts still and the low counts. There's only a very few of these colonies here that had high enough counts for us to even bother with a treatment. Oh, I'm sorry, so they had a single oxalic treatment in June. Okay, kennel bees, very productive. We don't breed off them unless they have very good honey production. There's the mite counts. Again, I let it go up in November and they bring it back down by themselves by March. Oh, here's all the slides I added. They need the right place. Okay. Here we go. So this is our second year colony counts. So look at the Lumerick yard. We go out there. I'm saying, boys, I want colonies at least I might count of 10 so I can test this time-all treatment. Look at all the zero counts. Look at all the counts of only 1 to 2 mites right here. I wanted colonies in bold that were high enough for me to run the time-all test. I couldn't, or the oxalic acid test. We had trouble coming up with enough colonies that had mites for us to run a test. It was not a problem most beekeepers complain about not having enough mites. I told my sons after this, I said, boys, if you find any colony with a high mite count anywhere, that's gold to me. I need high mite colonies. Bring them home so I can use them for experiments because we don't have enough colonies with high mites. There we go. Okay, there's your expected normal distribution. If the the average we saw was 16 mites. So if I do that with a Poisson distribution and standard deviation of 3, which got them out to what we see here, this is what you'd expect to see right here. And what we did see is the skewed to the left. Okay, that got out of the way. So we've got our fingers crossed. We're going to continue with success, maybe even hit a tip point. And that's it. Give me 1 second. I'll give you that that brand name. There you go. Vite.
Beet. Can't say I've ever had any experience with that, but
Well, I hadn't either. But you know, if you buy extras and you have them left over, you can put up a free stand outside that says free bikini waxing.
I'm not sure I want that attention. So a couple of quick questions. Thanks, Randy. I want to remind everybody that if you wanted to make any contributions to Randy's research and the information that he's made available for everybody, you can go to his website. There's a donate button on the top of the page. You can make contributions there. I think you list your donors on the website too as a thanks. Is that right, Randy?
Yeah, I do. Anybody who donates over $100 or more, you know, it costs me, if I have 2 assistants, you know, I'm talking $400 a day. And so it's, yeah, it costs money to do bee research, and I don't get any grants. I just get, beekeepers want the information. I figure they should just pay for it.
Yeah, that's right. Wayne, if you're still here, I think he had asked a question earlier about avoiding inbreeding, and you had answered that regarding the grandfather clause there.
Yeah.
Could you elaborate? And this one I think would be helpful for everyone. Quentin asks, could you elaborate on shaking from a brood frame being inconsistent?
Yeah, go on my website and look for the article on which frame should you take a sample from. And what happens is the standard deviation, the variability of brood frames is great. And I'm not the only researcher who's found this. Actually, the mite counts off of honey frames are lower, but they're more consistent. So what we found is the ideal frame to take one from is a frame adjacent to the brood nest. And then that way, not like the queen, you're not getting the emerging mites that are coming out right there. And you allow the bees, older bees, to fly off. So now you have nothing left in there but young bees that correlate closely with the overall infestation rate for all the bees in the hive across the whole way. Okay, I'm not understanding how breeding bees back to grandfathers avoids inbreeding. You don't breed them. Yeah. Okay. So the genetics of the drone come only from their mother, but the genetics of the mother came from the father and her mother, the queen's mother and father. So that's the virgin queen's grandparents' generation.
And
so the queen,
when the queen makes a delay.
Yeah, when a queen lays an egg, that those or creates either eggs or sperm cells, she's splitting her chromosomes. She got one chromosome from her father and one chromosome from her mother. So that means that the drone pop pool for any queen comes from their grandparents' generation. If we're in a controlled program, it seems to complicate things. I don't understand what it's complicating. It's really simple to me.
Yeah. Wayne would like to ask a question direct. You want to give that a shot?
Yeah.
Okay. Yeah, go ahead. Let me make sure you can unmute here. 1 second, Wayne. There you go. Give it a shot.
Woohoo. Okay. So can you guys hear me?
Yeah, we
Yes.
can hear you. Go for it.
Hey, thank you, Randy. This is fantastic information. It's like drinking from a fire hose.
Yeah, I've heard that before.
And so what I was if you establish a central breeding yard with out yards and you're controlling those genetics and you're using your own stock over time, it seems that that would gradually lead to a genetic bottleneck. So even
Wait,
if
wait,
you're
wait, wait, wait. Let's just stop. Read Rob Page from years ago about closed breeding population. What he found, if you breed from at least 30 different queen lines a year, almost in perpetuity, you will not get inbreeding.
30 different queen lines per year.
Yeah. And what we find is there's enough genetic diversity by simply looking for diploid drones and looking at color patterns. I watch very carefully. I have not seen any sign of inbreeding whatsoever.
So with that in mind, so there's really, if you're a small timer, there's really no way for you to do it. Is there a minimum number of hives that you would think you would have to have in order to do this successfully?
Yeah, I mean, probably 500. If you're fairly isolated, probably 1,000 if you have other beekeepers around. The more you can work with your neighboring beekeepers. So there's no other commercial beekeepers coming up into my area. There are only hobby beekeepers around me, and they're all very friendly. They all get their bees from me. So so very much and with our swarming and stuff going out to the trees, we pretty much can control our breeding. There's 2 studies by USDA years ago that showed that when they actually tracked bloodlines, they found you can control 95% of your matings by simply mating near your main operation.
Okay, thank you very much for clearing that up for me.
Yeah, and like I said, there's a feral population. I don't know how big it is out there, but they're not going to be producing drones the next year if they died from varroa. So I'm happy to allow them. Our feral, unlike Southern California, where the ferals are Africanized and you do not want them mating with your queens, we don't see any defensive, hot bees around here, and we have no problem maintaining very, very gentle stock.
Okay, I'm just in a very rural, secluded area, and it's I'm trying to kind of direct a little bit and trying to improve that that temperament of the bee. Right, I've gotten good as far as like the VSH is concerned. They're solid. It's just the temperament's a little bit.
Temperament's a really easy thing to negatively select for. All we do is on the top of the hive we write these 3 letters HOT. That's a kiss of death for that queen.
Now, Randy, you wouldn't discourage making attempts to step in the right direction to walk the walk, as far as
No.
if I can't manage 500 hives, but I can actually manage 100 within a 2 mile, 5 mile, 10 mile radius. I definitely can have positive impacts on what I'm seeing in my colonies. Is that right?
Yeah, and there's areas in the United States where the beekeepers are pretty much working with feral stock, and the feral stock, you can call yourself a queen breeder, but it's really Mother Nature doing the breeding. And what you're doing is you're taking the best that she offers and maybe selectively breeding for the most gentle of the feral stock. So just work with nature. That's, I'm not patting myself on the back saying I'm doing all this. I'm working with nature on this, and we're just simply selecting against those that are really high mite and propagating those that are low mite.
What's the range on your apiary spread for your model that you're using? Like, what's your furthest outer distance on your perimeter?
Well, we're over the county quite 20-minute drive in every direction, but we have a lot of, within a half mile to a mile, we have quite a few apiaries surrounding us. And we just had a discussion with we just got approached by a friend who's a large commercial producer who's interested in propagating the stock using getting bloodlines from us. So we're going to we're talking about shifting our breeding to even better control our matings. So yeah, we're taking this finding this year of, we had no idea how successful we've been. My sons, it's a fair amount of work, and so they, we're wondering, how we're doing, and finding out how much progress we made. All of a sudden, they are enthusiastic right now, and looking at, we're not trying to monetize this or anything like this or prove a point. We're just walking the walk for the other commercial producers to say, hey, if you use this simple technique from your own stock, how much it would cost and how many hours and how many years it's going to take for you to maybe breed resistant queens or bring in a stock and maintain it. Because this, even if you buy a bloodline that's resistant, if you don't follow this program and selectively and wash every single year,
You're gonna lose it.
It'll be outbred.
Yep, it'll wash out. Yeah.
It'll wash right out.
Yeah, for those of us running smaller operations, it could help us to bring in some of that vetted stock out of people that can raise those.
Certainly, and then propagate that.
And that's our philosophy.
Here's the thing with queen breeding: if you have a way resistant stock and you don't propagate that queen, you're not helping. Unless you're raising a bunch of daughters off those queens, you are not helping. If you're spending all time and money trying to keep non-resistant bees alive, you're not helping evolution at all. You help evolution by being ruthless. That means you don't propagate non-resistant stock, and you only propagate, and then you way propagate, raise queens from best. If you have I tell people who buy our stock, boy, if you got a 0 queen, keeps mite counts to 0 all year, let us know. We'll swap it back for her. We'll come out and graft off her. But it's a shame. It's a crime against nature not to breed off that queen.
I got some for you, Randy.
Okay.
Matt, you got a question for Randy? I think I sent you unmuted there. Okay, yep, you're unmuted. Go for it, Matt.
Hi, Randy. There's been a lot of talk recently about the uncapping behavior in bees, and you mentioned that you've seen uncapping behavior in both your resistant and non-resistant
This
stock.
was yesterday. So
okay.
I went out with my assistant. I just gotten back from Epimondia, and I said, you know what? Here's one of the projects I wanted to do this year. I wanted to compare the uncapping percentage on the resistant versus non-resistant, and she hadn't seen it before. So yesterday, this is only yesterday, we go out and I say, well, here's one of our resistant queens, and I put the pad on there, zipped it off, and I go, yeah, look at all the recapped cells. So let's compare it now to a non-resistant colony, one that we had brought back due to my counts to use for other purposes. And it looked almost the same. I go, oh, that's weird. Let's try another one and another one. And every damn one had a high amount of non-resistant. So I'm doing mite bioassays and treatments. So I'm bringing in these very high mite colonies, even collapsing colonies to our yard all the time to supply high mite colonies. So I know they're non-resistant. And every damn one, we looked at about 6 of them, I guess, they all exhibited high rates of recapping, which surprised me. So what that means is not just the recapping, it's also the varroa-resistant hygiene, the removal also, which then that's what gives you the spot, because recapping does not give you a spotty brood pattern. Only the removal gives you a spotty brood pattern.
Right. So having the one without the other is not beneficial. My other question then
regarding... I wouldn't say not beneficial, not adequate.
Okay. And
that's a big difference, saying not beneficial and not adequate.
And so do you think that the uncapping behavior is triggered by the presence of mites, or do you have colonies that have little to no mite load but still have a high degree of uncapping behavior?
It appears, the best I can tell, is triggered by the presence of mites. And I see that in those breeders where the mite level starts to go back up at some point in their lifetime, and then bam, they hit it, and all of a sudden you see uncapping behavior
everywhere
explode, and then they bring their mite counts back down. So this is maybe an epigenetic upregulation triggered by the odor of mites or of something else, but clearly something changes in their behavior that triggers that uncapping behavior.
Thank you.
Have you had any opportunity to look into or experience the UBO spray? That's
No, I've talked to Kira about it, but she hasn't sent me any yet. But I'm very interested in trying it. My get, if I were a betting man, I'd be betting that my bees probably would respond to it strongly.
Mm-hmm. Okay, let's see here. I don't see any additional questions. I think you covered a pretty good myriad of things that were beneficial to our audience, and we're very grateful for that.
Here's one. Do you plan to make any of your resistant stock available to others? Well, we sell 1,000 nukes and a few thousand queens every year. So, and we tell them we don't not claim resistance, but you got about a 30% chance you're going to get a resistant one.
Yeah, I've heard good things about your queens from quite a few people, and they're demonstrating some of the claims you're making. We won't pin you to it, but you're in the ballpark.
Yeah, no, yeah, I'm not making any claim of resistance at all right now. But yeah, the feedback I get is really is very good.
Someone says they'd like a few hundred queens. Is that an option?
We're pretty much sold out in advance of everything we can produce every year. Yeah.
When would you take orders for that? When would you start if you wanted to get some next year?
Yesterday.
Yesterday. Okay. All right.
How long do you think it will take to get? Oh, right. Let me get my crystal ball out on that one. I don't know if we're going to hit a tip point where suddenly it just flips, or whether it's continue at this same rate. I'm surprised it's taking this long with the. I mean, we typically wash 1,500 hives each year, and breed off of 30 of that. Okay, so hang on a second. I'm going to bring up my calculator. So 30 divided by 1,500 is 2%. Okay, so we eliminate 98% of our queen's genetics every year. We breed off of only 2%. Now we don't eliminate that because they're still in the drone pool the next year, but we're only breeding. That's strong selection. You know, that's 98. You're only breeding off of 2% every year after year. That's a very strong selective pressure. Back to your question, Jim, how many colonies do you need? To do, so that means if you had 100 colonies, you could breed off of half of one.
Yeah, I mean, but our philosophy with the Bee Guild is to start doing something. Don't just sit there and talk about it. There's nothing we can do. Yep. Yeah, and I've seen remarkable, I think, progress just in my apiaries, and there are queens that are demonstrating capacity to keep the mite loads down. There's queens that can't hang at all, and I'd say a few of them I could readily call bred from wild stock or feral stock, and those are evident, especially when you go out and cut them out of a tree and they were in there for a little while.
Oh yeah,
those are always nice.
I agree with Matthew also on his post just now. Matthew, I don't know if you know what a Punnett square is. Punnett square is where you show the crossing. It's 4 cells. Where you show the genetics of the father and mother, or the father on one side and the mother on the other. I've done Punnett squares 50 wide and 50 down, and I've done fancy Excel models to try to predict our progress. Every single one fails to predict how slow our progress. Everything I do says we got to be making faster progress than what it's showing. So what it's suggesting to me is that it's very complicated genetics. And we're not talking about just a few alleles. We're talking about regulatory pathways that have to all come together just right in enough of the patrolines to make the whole team work together.
Well, we're glad you're making progress, because it says that there's reward in the effort.
Oh, actually, there's light at the end of the tunnel. And it's time for us to get serious. And the only reason I'm doing this is as a demonstration project for the commercial queen producers. Okay. And they come out here and they visit me. They go, they show up and they say, oh yeah, I bet they're going to be hot. They're going to be lousy bees. I said, come on out here and help me do whitewashes all day. And at the end of the day, they go, wow, was I wrong? These are beautiful bees, and they look at these 0 mite wash counts and they can't even believe it. So that's all I want to do. I want to tell them, don't give up on this. Until we get the commercial queen producers selecting for resistance, we're not going to go very far.
Not very fast at all.
Right.
Yep. Well, thank you so much, Randy. Appreciate you. We appreciate the presentation, and thanks to everybody else for coming out tonight. We're very grateful that you came.